Hi everyone, welcome to the episode 14 of XCA ByteCast, a series of bite-sized tips and tricks that you can use in any of your projects. In this video, we'll explore how to build an actor-isolated timer using Swift Structured Concurrency and Task Sleep API. Let me show you the demo of the completed project here. So this is the demo application. The main UI provides a slider to determine when the timer will be triggered after specific interval in seconds, and also there's a toggle to determine whether it should be repeated or not. So let me set the timer interval, set it to be triggered every 3 seconds, repeated. Okay, and let me start the timer. As you can see, 1, 2, 3. Okay, so this text will be updated when the timer block is being invoked. Okay, every 3 seconds repeated. As you can see, 1, 2, 3 got updated. 1, 2, 3, boom, get updated every 3 seconds. Okay, so under the hood, this is not using the plain old NSTimer or dispatch timer source. Instead, it is using actor isolated timer with Swift structured concurrency to sleep the current task execution context without blocking the thread. We will build one that uses a main actor for isolation and the other one that uses a custom global actor for isolation. I recommend you to watch the previous episode 12 and 13 videos as well if you want to learn more about isolation context, main actor, and global actors. Links are in the description below. Okay, so let me close this demo. Okay, so if you plan to come along with me, please download the starter project from the GitHub repository link that I have provided at the description below. So let me give you a brief overview of starter project. So this project itself is configured to use the Swift 6 language with Swift concurrency checking set to complete. Okay, so basically any data rest possibilities across isolation boundaries will fail at build time. Okay, that's one thing when we are using the strict concurrency checking set to complete. If you see in the view model, currently the timer is using the standard NSTimer for scheduling the code to be executed given the timer interval, as you can see in here. So before it start the timers, this timer text is updated with the current date. So it will be displayed in the UI using the text with that timer style. Okay, to display the timer per seconds. And in the execution block, even though this runs on the main thread, we cannot update the UI directly. Okay, so if we try to do this without switching to the main actor extension context, it will throw this error, right? Because we have enabled the Swix 6 complete strict concurrency checking call to main actor isolated instance method in a synchronous isolated context. Okay, so by default, this execution block run in the non-isolated context, and to update this view model itself is tied to the main actor isolation context. So we cannot just update the property in here because this runs by default in the non-isolated context. So that's why we need to switch to the main actor isolation context explicitly before updating the UI. Okay, and in the update UI itself, it will update the UI accordingly. If the timer is completed, it will just stop the timer and clean up the properties, the timer text, so it won't be shown, as well as setting the timer to nil, invalidate it and set it to nil. And then if not, when it is being repeated, it will keep on just setting the fire out text with the current date and reset the timer text to display the countdown for the timer in every seconds in the UI. Okay, so that's it for the starter project overview. So let's begin. So first I want to provide a brief overview of the existing solution for timer based API. So I've created a slide containing the key points. So first is the NSTimer. So this is basically the API used most by us when we want to create a timer and then update the UI when the execution block get executed. So this is basically tied to run loop, which is a loop that handle the import sources like timer and events. And it only fires if the run loop is running. For example, the main thread run loop will always be run when the app process is not being killed. Okay, and or suspended. Also, the execution block, like I mentioned previously, runs in the non-insulated shift concurrency context. And as you can see, the API is pretty simple to use, like this. Okay. And the second solution is to use this low-level dispatch source timer. So this is more accurate than NSTimer, and we can configure it to run directly on GCD queue that we want. So we can use main queue or any other GCD queue or create our own queue, and it's not dependent on the run loop. And also the life cycle is a bit more advanced because it supports suspend and resume. And it is more complex to use and manage compared to an NSTimer API. So this is mostly used when we want to run the timer in a thread other than the main thread, because NSTimer will always usually run in the active run loop, which is only the main thread. We don't want it is very cumbersome to create our own run loop in different thread, right? And that's it, basically the existing solution for timer based API. So you can read more about them in detail from the documentation. I have provided the link to the official documentation for them at the description as well. Now let's begin to create our actor isolated timer with Swift structured concurrency that mimics the NSTimer API. Okay, so let's begin by creating a new Swift file. Give it a name of actor isolated timer. Okay, and first let's declare a class main actor isolated timer. Okay, and let's basically mark this to run in a global actor, main actor, using this main actor. Okay, so this means this class will always runs in the main actor isolation context. Okay, and let's declare several properties. First one is the task, void and never. Okay, so this will hold the task when we perform the task slip later. And sorry, this one should be optional in here, not in the never. And next, let's declare a private set boolean to determine whether this timer is valid or not. The default will be true. Okay, so when this timer got initialized, we will immediately start the timer countdown. Okay, and let's create a method invalidate. This is very simple. We will just add this valid to false and then cancel the task. Okay, and we will set the task to nil. Now let's continue by creating an initializer. So for this initializer, I want this to run in a non-isolated context, so it can be initialized anywhere. It doesn't need to be bounded to the main actor isolation context. Okay, so just use this non-isolated keyword and then init. And first parameter is the time interval. Okay, second one is whether it should repeat or not, repeats. And third one is this clock type. So the default value for this will be, so this clock type is a type that we declare ourselves. If you see this clock type, I've created this enum clock type. Okay, suspending or continuous. This will help us later when we want to initialize the suspending or continuous clock, as it can be a bit cumbersome because of the generic constraint. Okay, the default value is continuous, and then we're going to have a execution closure block. Here it's going to be escaping sendable as well, and we're going to isolate this execution to the main actor isolation context. Okay, and we will pass this main actor isolate timer instance as the parameter. Term type is going to be void. Okay, so this is the initializer and the parameters. So basically now inside this initializer, we will initialize a task immediately, okay? And then we're going to tie this to the main actor installation context, and in here we're going to make this weak self to avoid any memory leak issue, and guard left self else return, okay? And in here we're going to assign this task property by initializing a task, okay? Again, weak self to avoid any memory leak. So this task itself will inherit this main actor installation context, okay? And in here we're going to check again the self is not nil. And now let's declare a var is running. The for value will be true, okay? And we will basically use this repeat block, okay? Repeat while is running is true. So as long as this is running variable is true, this repeat block will always get executed, okay, repeatedly. So now inside this repeat block, let's declare a do catch block, okay? So in the catch block, now we're going to just check if the error is cancellation error. If the error is cancellation error, we're going just to print timer is cancelled for debugging purposes. And we're going to break out of this repeat block by setting the is running to false. And we're going to invalidate as well, okay? So this is fault is set to false. So that's the catch handling. Now in the do, there are several things that we need to do. First, we will declare this nanoseconds, okay? We will convert this time interval to nanoseconds with the unsigned integer 64, okay? So let's declare this unsigned 64, and then we're going to basically multiply it with 1 billion, okay? So this will be nanoseconds. And next we will basically check if the clock type is continuous, else, okay? So if it is continuous, we're going to initialize a continuous clock, and if not, we're going to initialize a suspending clock, okay? There are only two possibilities, continuous or suspending clock. You may be wondering what is continuous clock and suspending clock differences, okay? So let me show you in here the differences between them. So continuous versus suspending clock differences. In terms of time tracking, basically the continuous clock will always continue to be counted during the system sleep, while the suspending clock will pause during the system sleep. For the accuracy, the continuous clock will measure about the absolute elapsed time. Suspending clock itself will measure active time. So when the system is sleeping, it will basically get paused, okay? And the use case for the continuous clock, it is used for the benchmarking or strike timing. Suspending clock for the user facing delays or real world time, okay? So basically based on my observation, right, at least on iOS, using suspending clock system is never suspended even if we move the app to the background or set the iPhone to standby using the lock button, okay? So while on the Mac OS, when I put the system to sleep, for example when I close the lid of the laptop, it will pause the clock until the system is reawakened, okay? So I think on iOS, using suspending clock for timer doesn't really make a difference. But remember, right, the line after the sleep won't be executed if the app is in background state on iOS. So it will be executed after the app is being bring back to the foreground state, okay? So you need to consider those on mind. So by default, in the task sleep API, it will use the continuous clock, okay? And then in here, we can simply invoke try await. So there are two API for this. You can use task sleep for nanoseconds passing the clock, okay? And we can also use clock.sleep. Sorry, the instance clock.sleep. So this is for the instant base, and this is for the duration base. Okay, for duration, this is for instant. So I'm going to use this instant base API. Okay, so until now plus nanoseconds, and we're going to pass the nanoseconds. Okay, so for the tolerance, let's just pass 0. Okay, so by using 0 as the tolerance, basically it will provide the best precision, sacrificing the power efficiency. You can also pass tolerance in the initializer if you want, but for now let's just pass 0. Okay, so for example, you want the tolerance to be like, it's okay to be delayed by 100 milliseconds, you can do it. Okay, that will provide a better battery life, but for us, let's just pass 0 as tolerance. Okay, for the best precision. And let's copy this and use the same one. Okay, so you may be wondering why we are duplicating this invocation to the sleep. So this is just to make it a bit easier. Okay, because this sleep itself, this duration is using some generic base constraint. Okay, so it's a bit simpler to just divide the invocation for each of the clock instance, whether it's continuous or suspending. Okay, so now we already invoke the sleep, so it will sleep the suspend the thread, but it won't block the execution of the thread. And then after this is got resume, we can simply check if this task is already cancelled or not, using the try task check cancellation. Okay, if it is not, then we are going to continue by setting this running with the repeats. Okay, so if the repeat is false, this is running will be set to false, breaking this repeat loop block. And now let's check if it is, if not running, we'll just basically invalidate this timer. Okay, and next let's kick off a child tag so it won't block the execution block using weak self again. So in here we can simply again use the guard let self else return, and now we can invoke the execution block passing self. Okay, that's it for the timer implementation. So let's go back to the view model. Okay, and then let's replace this timer with the main actor isolated timer, and replace this start NSTimer with the start main actor isolated timer. Okay, start main actor isolated timer. So we don't need to use this boolean to determine this is complete or not. By copying this repeat, we can simply pass whether it's complete or not by checking timer is valid. Okay, so this will pass us the timer in here that we can use to check. And we don't need this task main actor as well. Okay, let's just initialize it using this timer interval, this repeats, clock type, and the block weak self. Okay, now let's just copy this. Timer in. Okay, so yeah, we don't want to switch the isolation context anymore because this already runs in the main actor isolation context. Okay, so let's try this. Let's change the target to mac. Okay, it is running now. Okay, 3 seconds, repeat. Let's start the timer. 1 2 3, boom. 1 2 3, boom. 1 2 3. Okay, nice. And if you see this, it's going to be always this print thread current will always be main. Okay, now let's stop this, and yeah, we have successfully implemented our main actor isolated timer. Okay, nice, right? Using the task sleep API. Now next one, let's say we don't want to run this our timer always in the main actor main thread. We want to run it in the other isolated actor. So for that, let me show you how to run it using a custom global actor. So in this main actor isolated timer file, let's declare a global actor. Okay, custom global actor. Let's give it the name of my timer actor, and let's create the singleton my timer actor. Okay, so for this I'm going to just copy and paste this. Okay, and I'm going to change this to my timer actor and change this the name of this to the my timer actor isolated timer. Okay, and I'm going to update this execution block to be executing the my timer actor isolation context and the instance to the my timer actor isolated timer. And here I also need to update this task to be executed in the my timer actor. Okay, so this will run, but currently the function, if you see, right, the logic in here is being duplicated. So as of now I don't really know how to reuse function, because every time we declare a function it will always be tied to a non-isolated or a specific isolation context. Okay, so for simplicity this will work duplicating this, but yeah, there's a bit of duplicating, but for now it should be okay. If you know how to handle the reusability of a function that can be shared across isolation context, let me know in the description below. Okay, so yeah, this is the main timer actor slot timer. It won't run in the main thread or main actor. Okay, it will run on this global custom actor. So for this we simply need to, so let's say we want to use this in the view model, we don't want to use the main actor as a timer. We can simply, for now let me just copy and replace this to my timer actor isolated timer. Okay, and this as well, I'm just going to comment star my timer actor isolated timer, and here just change this. Okay, but when I try to build this it will give an error. Okay, call to main actor isolated instance in a synchronous global actor my timer actor isolated context. So why is this happening? Because if you see, this view model itself runs in the main actor isolation context. Okay, and this execution block run in the timer actor isolation context, so we cannot simply invoke this. Okay, so one thing that we can do is we can simply switch to the main actor isolation context in here using this, and then update this. Okay, we need to invoke await. So this will solve the problem to update the main actor. So there's another problem. So call to global actor my timer actor invalidate in a synchronous main actor isolation context. Again, same issue. This stop timer runs in the main actor isolation context, and we try to invoke this my timer actor in a different isolation context. So it will give this error if we enable it shift 6 complete strict concurrency checking. So to handle this we need to switch explicitly to the my timer actor isolation context. Okay, and then we simply need to invoke timer invalidate. Okay, so that's the strategy. I need to update the invocation. Start my timer actor is loaded timer. Okay. Okay, let's just start the timer. 1, 2, 3. Boom, updated. 1, 2, 3. Updated. Okay. So let's see the thread. If you see the thread now, it's not running in the main thread, right? It's running on the thread given the my timer actor execution context. Okay, as you see, the thread is keep on being switching. Okay, but the execution context is tied to the my timer actor global actor execution context. Okay, so this is very useful if you don't want to execute the timer in the main thread. Okay, but here we can explicitly switch to main actor if we want to update something in the main thread. Okay, so that's basically it for this tutorial. We have successfully created our own actor association timer that adhere to the shift strict concurrency checking. Okay, and with the capability of using a main actor isolated timer or a custom global actor isolated timer. So I hope you learn a lot from this video because I also learn a lot while experimenting this. So I still learning, try to learn a lot of new things for this safe concurrency because this is very new to me as well. Okay, so please provide any feedback. Okay, if there is mistake when I'm implementing this. And that's it for this video. Like the video if you like, subscribe if you haven't, and let's keep on being a lifelong learner. Until the next one, goodbye.